Hello class. Today we're going to be looking at inscribed angles. These are angles that are drawn within a circle. Let's take a look at our first theorem. It states that the measure of an inscribed angle is half the measure of its intercepted arc. So that's going to mean that our formula, the measure of angle ABC, and I'll draw those for you, is equal to 1/2 the measure of arc AC. So if we have three cases on this. If we have circle X, B is going to be the vertex, and we're going to have A and C as our endpoints of our arc. So in case one of the sides of our angle ABC goes through the center. So BC is a diameter. But in this case, whatever AC is, half of that is this angle ABC. Now, it doesn't have to go through the center. We could have A and B, so that AB and BC are on separate sides of the center. Or we could have A and B, or A and C, make that arc so that when you do draw BA and BC, it's only on one side of the center. But in any of these three cases, this is the formula that we will be working with. So let's take a look at our examples down here with our newfound information. So we have this circle, and we're trying to find the measure of angle PRU. So we want this measure. Now that's going to equal 1/2 of the measure of the arc PU. Well, PU is 118. So we're going to take 1/2 of 118, and we'll find that the measure of angle PRU is equal to 59 degrees. The next one, we want to know the measure of the arc. So the measure of arc SP is going to be twice the measure of angle PRS, or SRP. So SRP is 27, so we're going to have 2 times 27. So the measure of the arc SP is going to be 54 degrees. Now this next one that we have has a lot of information on it, and we don't have to use all the information. We just have to figure out which information we do need. Now they're asking us to find the angle of DFA, which is this angle right here. What we do know is that the measure of arc CB is 164 degrees. So this CDB and CEB and CAB are all going to be half of that, or 82. Now, they also gave us this information right here that angle DCF is 33 degrees. So DCF, if I look at that triangle, I can find this angle CDF. It's going to be 1/2 of 164, and that's going to give me 82. So I can find then the angle of DFC by taking 180, and I'm going to subtract the 82 and the 33. And that's going to give me 65. So if this is 65, CFA is a linear, so it's 180 degrees. So if I want measure of angle DFA, I can take 180, subtract the 65 degrees, and that's going to give me 115 degrees. And that's what I was looking for. Let's take a look at another theorem. It says, if inscribed angles of a circle intersect the same arc or are subtended by the same quarter arc, then the angles are congruent. Subtended is a word that we don't usually use a lot, so let's take a look at what subtend means. Subtend means to extend from one side to the other. Oops. Let's get everything so you can see it all. So if I have angle or circle X, and I have a chord A, B, and I'm going to make intercepted chords C, D, and E from there. So if I put angle C here, or point C here, and I create angle ACB, well, that is going to be congruent if I to another one here, D. If I make angle ADB, let's do one more, and let's put this one on as E. AEB. Well, every single one of these angles are congruent. Now, along with this too, we have an inscribed angle that subtends or moves from one end of the other to the other is a semicircle, which means it's going to go through the diameter, right? So if I have, let's call that J and K, and J and K would be endpoints of the diameter, and we have an angle over here, and we'll call that M. This angle, JMK, is equal to 90 degrees because it subtends a semicircle, which means that that hypotenuse would go through the diameter. That makes this a right angle. So let's try some here where we're going to find some values on our examples. This one, it wants to know the value of A. Well, because WZY subtends the circle, or the semicircle, that's going to be a right angle. So we can state that 5A plus 20 is equal to 90. So we'll subtract 20 from each side. 5A is equal to 70. If I divide by 5, A is equal to 14. On this one, we're looking for this side, the length or the measure of an angle L, which is here, and J and M. So I'm looking for this little point. Well, this angle subtends the same arc as this angle KLM, so I can put those two equal to each other. 5B minus 7 is equal to 3B. If I subtract 3B from each side, I have 2B minus 7 equals 0. I'll add 7, 2B equals 7. So B, if I divide by 2, is 3.5. Now that's not what they were asking. They want to know the measure of that angle. So I will put that into here. 5 times 3.5 minus 7. Put that into my calculator, and I'm going to get 10.5 measured in degrees. One more theorem before we're done today. If a quadrilateral is inscribed in a circle, so I've got circle C, and I put a quadrilateral in here. Let's make this W, X, Y, and Z. Then it says its opposite angles are supplementary, so that means you add them up and it equals 180 degrees. So this angle added to this angle, angle W plus angle Y is equal to 180 degrees. Same thing for the cross the other way, angle X plus angle Z is equal to 180 degrees. Let's see what we can find out on this example. It tells us that they want to find the measures of all the angles. So we want to know angle G, angle H, angle J, and angle K. Well, looking at what I know that G and H are going to add up to 180. So I'm going to go 6B plus 20 plus 3B plus 25 is equal to 180. I will combine my like terms and I'll get 9B plus 45 is equal to 180. Subtract 45 from each side, we'll have 9B is equal to 135. And we'll divide by 9. B is equal to 15. So G is going to be 3B plus 15, or 25. So I'm going to go 3 times 15 plus 25. That's going to give me 70 degrees. J is going to be 6 times 15 plus 20. And that's going to give me 110 degrees. And notice that 70 plus 110 do equal 180. I also can find angle K by substituting 15 in. I'll have 10 times 15 minus 69, and that equals 81. Now I don't have a value for H in terms of B, but I know H plus K is going to equal 180. So if I take 180 and I subtract the measure for K, that will give me the measure for H, 99.